Good morning, everyone, and welcome to the first webinar in our Beyond the Asset series. I am Chris Moy, Catchment Management Team Leader at Stantec, and I will be chairing our session today as we discuss parallel investigations undertaken by the Rivers Trust and Stantec to assess the opportunity for nature-based solutions in support of Severn Trent Water in meeting their wastewater WINEP obligations around phosphorus. Phosphorus, that's what it's all about, this webinar. So phosphorus, one of the main reasons, as I'm sure you all know if you're on this webinar, for water bodies failing to achieve water quality objectives. The challenge going forward is that as standards tighten, you need to, the technological challenge is harder. It means it's more difficult to achieve the objectives of reducing phosphorus from discharges and meeting the challenges of the phosphorus reduction targets in the water bodies. The problem is that as you throw more technology at things, obviously that's more process, that's more carbon, that's more chemicals, that's all those things. So that's really the ground we're going to cover today. Now, one way to approach this is to consider hybrid solutions. So what are hybrid solutions? So hybrid solutions, instead of just applying a standard treatment technology, you can blend that treatment technology with other opportunities to reduce phosphorus. So that could be nature-based solutions or catchment solutions or other forms that provide some sort of phosphorus reduction in addition to a traditional treatment approach. The benefit of that is that by doing that, I'll talk about technology tipping points in a minute, but the benefit of that is if you can take the phosphorus technology, relax the permit a bit so you can get to what we call a technology tipping point. You can use a less energy intensive technology in the treatment plant, and then you could add your other components of your hybrid solution, and that blend together can lead to lower carbon solutions, more sustainable solutions. It can help with flooding, and there's wider socioeconomic benefits as well. So one of the things that's facilitated hybrid solutions is flexible permitting. So in recent years, there's been a number of pieces of guidance and regulation that have come out that have enabled this. So we can move much more towards permitting across a catchment and looking at achieving an overall catchment phosphorus load reduction, rather than just focusing on an emission standard at each and every works treated individually. So that leads into things like catchment permitting across different works, or catchment nutrient balancing, where you can look at the phosphorus reductions not only across the works but also with contributions from nature-based solutions. And all this is also all this is also based around fair share principles. So you'll have the fair share for the water sector, the fair share for the agricultural sector, and so on. So what does it look like, these sorts of hybrid solutions? Well, on the left there, you've got a series of boxes, and they're the sort of solution components. So you might be looking at moving some flows from one works to another. You might be looking at technology, and I'll just pause on the technology tipping points again there. So if your permit is at a particular level through WINEP, if you can relax that permit a bit and therefore perhaps have less process, perhaps 1-point dosing rather than 2-point dosing, that affords you the opportunity to reduce your carbon footprint. And what enables you to do that is if you can bring into play nature-based solutions. There's also aspects around, is the permit correct in the first place? So are your flow estimates correct, which is what the DWF headroom refers to there. The SAGES model that is used to derive the WINEP permit, how reliable, how robust is that? Russell will talk about that later in his slides. And then, as I said, there's flexible permitting and catchment permitting you can look at. And then there's the opportunity to bring in nature-based solutions. It could be wetlands, it could be reactive media or whatever. The graph on the right just shows sort of what happens if you do this. So this was a piece of work we did that we looked across 40 projects, quite a lot. And the dark blue line basically is the carbon footprint over 40 years if you use traditional treatment only. And the light blue line is the comparator if you go with hybrid solutions. So what that tells you is that after 40 years, you've still increased your carbon footprint through the phosphorus treatment, but you've more than halved it relative to a treatment only solution. So that's that's where you can get some benefits from that. In practice, what does this mean? So this little schematic is a river. At the top of the river on the north bank, if you will, there's a series of WINEP permits. So this is a real example where we had 4 works down a river reach with 0.5, 0.5, 0.5, 0.3 permits. We looked at the top of the reach, that little sort of squiggly line. That's some catchment benefits we identified in the upstream catchments. And then on the lower bank, the south, excuse me, the south bank, we've got the hybrid solutions, and the pie charts are basically, just indicating that you've got a treatment solution plus some contribution from catchment, perhaps through farming, addressing certain farming practices, and therefore providing a phosphorus reduction there. It could be through wetlands, it could be through a number of things. And if you look on that south bank, you can see that the permits go 0.7, 0.7, 0.7. So they're all slightly relaxed, which enables us to get to a technology tipping point and therefore a lower carbon footprint. And the last one in the chain, you can see it was 0.3 originally in WINEP, but we're actually suggesting 0.25, so a slightly tighter permit. However, because it's still in the same technology band, it doesn't increase the carbon footprint. So overall, across those 4 works and across that water body, you'll get reduced carbon. It supports sustainability and biodiversity. So what we're going to go through today is I've set the scene. That's me, Chris, at the top there. I'm going to hand over to Russell in a little bit, and he's going to focus on the evidence-based aspects of it. He'll talk a little bit about SAGIS and about farm scope and source apportionment. And then David's going to talk about the lessons learned in assessing the potential for wetland opportunities. And in particular, he's going to talk about integrated constructed wetlands. And then Alex is going to provide some real perspective from Severn Trent in terms of the AMP7 program, how you can maximize catchment nutrient balancing benefits, the timescales involved, and some of the challenges around things like baseline monitoring. Introducing our panel today, we have myself, and then also Russell Smith, who's a technical director at Stantec. David Johnson is joining us from the Rivers Trust, where he is technical director and also the catchment-based approach national technical team leader. Then we also have Alex Cook, principal consultant at Severn Trent Water. So let's pass over to our first speaker, Russell.
Thanks for the introduction, Chris. As Chris mentioned, I'm focusing a little bit more in the detail around the evidence base. So looking at opportunities for catchment nutrient balancing and specifically through on-farm measures. So I've been with Stantec a couple of years, but prior to that, I had a life in the Rivers Trust, and I've been doing kind of catchment sort of water quality planning work for the last 20 years in consultancy research and third sector setting. And we as Stantec have been supporting Severn Trent's environmental protection program, Severn Trent Water's environmental protection scheme steps since AMP6. So over the last 6 months, we've been moving, looking at the wastewater side and opportunities in the catchment to reduce phosphorus load through on-farm measures. So this talk is going to go through the evidence base. These are the objectives of the project. We're trying to understand or contextualize the phosphorus sources in the upstream catchments from a source pathway receptor, following a source pathway receptor approach. As Chris mentioned, a lot of the evidence base is reliant on models. All models are wrong, so we're trying to assess the confidence that we have in the outputs with some of those models that underpin the WINEP obligations, and for that particular model is called SAGES. Then we're conducting evidence-led review of what opportunity there is in the catchment to reduce phosphorus loads through on-farm measures, and then what that means in terms of how the WINEP proposed permit could be relaxed a little or revised to, well, reduce cost, avoid one of these treatment tipping costs, but also provide wider benefits in the catchment. So this is what we're looking at. There's 14 sites, well, 14 wastewater treatment works we're looking at, centered around Birmingham. They're all fairly similar in that they're all located in or near headwater catchments. They all have relatively small population equivalents, so there's an extra bit of challenge in meeting some of the tighter permits. So the map shows you each of the sites. We've sized the blue squares based on the population equivalent. Each water body is coloured up based on its current WFD status for phosphorus. So lots of moderate and poor, even one at bad. And then the number next to each of the works is the proposed WINEP permit. I don't think any of these works currently have a phosphorus permit. So the work we've done has followed a phased approach because, well, for a number of reasons really. We wanted to knock out some sites early on that really had where there was no opportunity for catchment nutrient balancing, and so do a high level screening, but also there were some fast track sites that we had to sort of push through. Well, 5 fast track sites we had to push through the process fairly quickly. So phase 1 was very much desk based, based on using the models kind of out of the box, if you like. So we did some high level farm scope and modeling based on the default information and assumptions behind farm scoper. We did, as Chris mentioned earlier, a sense check of SAGES performance to provide some initial screening, and then it was those sites that we then took forward and did some ground truthing with local farmers, local advisors who had specific local knowledge of each of the catchments and the farming landscape within them. So the second phase is we kind of revisit the modelling exercise, but it's nuanced to the landscape and the farm businesses within that landscape. So we get much more robust estimates of what is achievable in terms of phosphorus reductions in phosphorus loads in the catchment. We knit all that together in a concise summary report that sort of draws all the evidence base together. And then we've done some spatial mapping as well to draw the evidence together to help target both advice and measures. And we're currently just finishing up a high level cost benefit analysis. I put phase 3 in this schematic as well. We haven't started phase 3 yet. It's still up for discussion, but just really to say, we're doing the desk-based exercise. This will move forward into delivery, and the measures that we're looking at will be captured in something called an operating technical agreement that's aligned with the permit at these schemes. So this schematic sort of, well, these two sort of histogram schematic, if you like, cover sort of the 2 key strands of the evidence base. The top schematic, the histogram on the left represents the current P load in the catchment that is driving or causing, if you like, the current poor, moderate, or bad status. Using SAGES, that's then picked apart and apportioned to different sector sources. So following fair share principles, you end up with a target. Well, you end up with a target load reduction, and following fair share principles, you can then allocate that reduction to different sectors. Now, we've simplified this a little bit. We're working in headwater catchment, so the two key sectors are agriculture and wastewater treatment works, but SAGIS also looks at other sectors as well, including urban, highway runoff, septic tanks, intermittent discharges as well. And the second histogram below is where we've used a different modelling tool called FarmScoper. So if you note the histogram on the left, in the lower plot, represents the current agricultural load, and then we're trying to pick that apart to understand, well, you know, where are we currently? What is the current current load that can be attributed to agriculture? What would it look like if all agriculture in that catchment was compliant? And then what is available for catchment nutrient balancing? So Chris mentioned I would cover a bit on SAGIS, which, if you remember the last slide, is the top histogram. So it reflects both source apportionment and underpins WINEP obligations. Now SAGIS was calibrated for a baseline period from 2010 to 2012. So we've looked at the performance of the model in each of the downstream monitoring points, downstream in the assets, across the water bodies of interest. So these triangles, if they're pointing up, it means the model is over predicting. If they're going down, it's under predicting. Amber, well, there's actually four colors that we've used here. Blue, if it was on this plot, would mean it's within 10% of the 3-year annual average during the baseline period. Green would be within 25%, but amber is over 25%, but within one standard deviation, and red is outside one standard deviation during the baseline monitoring period. So on the face of it, it looks like we've got pretty bad SAGIS performance, or pretty poor performance across the whole area. But then if you drill down into that, and if you look at the plots on the right of the slide, you can kind of see, well, in these headwater catchments, you know, the monitoring is pretty sparse. So we're actually calibrating against 3 samples taken over 3 years. So it's really difficult to have confidence in what SAGIS is telling us, because the triangles are saying we're overperforming. But then if you carry that forward and look at you know, more recent, or the trend in the annual average over the last 10 years, you can actually see, well, there's an increasing or declining trend in water quality. For example, based on the top plot and the bottom plot, it's a bit more statistically robust in the top one. But if you roll forward to current, you know, SAGIS isn't actually performing that badly, but it does raise a bit of a question for me here on the calibration of SAGIS, and therefore which does underpin the sector source apportionment when it's being calibrated against just 3 years, 3 samples over 3 years, and over a very wide geographical area. So we just need to be mindful of some of the certainty around the evidence base. So the next strand of evidence that we looked at, which was represented earlier in the lower histogram, is a modelling tool called FarmScoper. Now, FarmScoper is a farm systems model. It's driven by agricultural census data, and it represents baseline loads, and through I think it's 104 measures that are represented in the Cutall manual. What reductions you can get through implementation of those measures. So this map shows you it's color ramped, so the darker colors show you where you're getting the bigger reductions, and we put the reductions in the water bodies themselves as well. The numbers next to the names of each of the works are the reductions we're trying to achieve at the works. But this is our phase 1 screening. So this is using FarmScoper kind of out the box, and we've done some what we're terming bookend assumptions. So our baseline load is farming practice in the catchment isn't particularly good. There's no prior implementation of measures, which is, if you like, the worst case scenario. Then the best case scenario is all measures, all steps measures, everywhere. So we've taken the difference between those two as our bookend value, and for screening purposes, assumed 50% of that reduction is available. So these are not realistic numbers, but they facilitate rapid screening. So these are the results that came out of our phase 1 exercise. We were very keen to not take all the sites forward, because as you go through the phase process, you're gathering, interpreting more information. So it's taking more time, more cost. So based on this phase 1 screening, 3 sites dropped out. Abbots Bromley dropped out based on a tipping point, basically with Abbots Bromley and a revised consent of 2.5. It was kind of all or nothing, and we fell just slightly short of that, although there was quite a lot in the catchment. And then if you look at another site that fell out at the end of stage 1, Worthing, there just wasn't much in the catchment to facilitate any offsetting. So those 2 sites, along with Croxton, dropped out. So the next stage, really, given that I've just said our initial bookend modelling isn't realistic, was to try and get more realistic and robust FarmScoper models based on ground truth evidence. And we used the local knowledge of farming advisors from organisations, well, Severn Trent in-house, but also some of the third sector delivery organisations who were working and providing farm advice in the catchment, so have knowledge of the catchment and the farming landscape within. So the 2 key areas of the evidence base that we ground truthed here was the land use or stocking densities, and the prior implementation of measures. Now, we assessed the prior implementation measures against the FarmScoper's default values. So if we'd used FarmScoper out of the box here using their default, we would have been out by we would have been even further out for over 50% of the sites. Sorry, just under 50% of the sites. So we gathered some really good local intelligence here, really, to really refine that modelling step. And now these are the results from the phase 2 modelling. I'll firstly draw your attention to the scale on the side. The histogram for phase 1, we went up to 4 here, so we've come right down, but we've got much more confidence in the load reductions we're saying we can achieve. And then bringing this information back into SAGIS and the optimizer tool, we could work out, well, what did that mean for what was the extent of the load reduction, and what did that mean in terms of revising the WINEP permits? So if you got the WINEP permit on the top line, if you realised all of the load that we're saying is achievable in the catchment, you could revise your permit to the middle line of this table. So all of these, with the exception of Yockleton, would be combined solutions. So to align with Environment Agency guiding principles around catchment nutrient balancing, you have to over-deliver by a factor of 1 to 1.5, which accounts for some of this uncertainty, both in the evidence base and the effectiveness of measures. Yockleton was the only site where there is potential, and it's important that we say it is potential to offset fully. So the other thing we did, or moving forward, we're now kind of thinking Actually, if I just go back to that last slide, one more point I want to make on that. When I'm talking about potential, we need to be careful here as well, because what we've done is identified the maximum loads you could achieve within the catchment, but we also need to consider fair share in this argument. And there's a bit of uncertainty for me around fair share at the moment, and what constitutes agricultural fair share, and is there a mechanism to achieve that going above and beyond compliance? So word of caution, in the load of reductions that we're saying are achievable in here, there is still an argument or a discussion to be had in terms of what constitutes fair share. And in any schemes that Severn Trent would promote, it should not avoid the farming or agricultural sector meeting its own fair share. So moving on from that, the next steps, we're sort of moving towards delivery, and everything we've done at the moment has been quite desk based. So now we're trying to bring all the evidence base together in one place to help with the next phase, which is delivery. So we're doing quite a lot of spatial analysis, bringing erosion risk modeling tools, outputs from those tools, together with some satellite imagery work to identify features in the landscape and really help target that advice and where measures may sit in the landscape itself. And then this is my final real slide. Moving on, we're hoping to continue to support Severn Trent to understand and ensure we've got a common interpretation of Environment Agency guidance principles and key issues around, what is fair share, what's the baseline, to ensure we're all working on the same page. Chris mentioned, why we're doing this in the first place. It's really for these wider benefits. So we're going to do detailed cost benefit analysis to look at wider benefits associated with carbon, biodiversity, understand risk of failure of working on third-party land. How do we measure performance and assess the success of a catchment nutrient balancing trial, and wrap that all up in a detailed catchment solution plan. So that was my last slide, and Dave, you're up next. So Catherine, if you can move across to Dave.
Morning, everyone. So I'm going to talk about our experience with designing wetlands for wastewater treatment, and a bit more widely about nature-based solutions as well, and how they can be assessed on an equal footing with conventional engineered solutions. And one of the reasons I'm here is because in a previous life I used to design sewage treatment works, and so I'm particularly interested in how we can work more closely between catchment partnerships and engineers, because I think there's a real opportunity there if we're going to optimise environmental delivery. So a quick introduction to wetlands, just in case you don't, just to make sure that everyone kind of gets what we're talking about. An integrated constructed wetland is basically a series of shallow wetland cells, sort of less than 200 millimetres deep. And they've been used successfully to provide direct treatment, so that's just taking in the raw sewage, provide the full treatment, or they've also been used for polishing, so particularly to remove phosphorus. And they're kind of based on the same principles as any treatment process, concentrating and focusing the kind of physical and biological processes to provide the water quality that you're after. And the only reason why they're kind of called integrated is because they are integrated into the landscape as a whole to provide greater benefits in terms of biodiversity and cultural benefits as well. So first slide really is starts with a bit of an obvious statement, but nature-based solutions just have to be designed in the same way as an engineered solution has to be. And that first graph that I've got up there is just from another project I'm doing on natural flood management, where we're modelling the catchment or the key features of the catchment initially, so that we know what bit of the hydrograph we're targeting. So it's, you know, we're following the same kind of principles as any design, because I think nature-based solutions need to be seen on an even kind of footing, really. And what I'd say in terms of the wetland and the lessons learned are that we've the first point was around hydraulics. So, you know, I work for Rivers Trust, we're environmental NGOs, and I think from a hydraulics point of view, I think it's fine for engineers. But to be honest, it's and you know, and the situations we had were rarely complicated. But I think for an NGO, this is where they could make the mistakes with the hydraulics. There's no, you know, I happen to be an engineer, so it was fine for me. But I think that's where we need to be, where we would need to be careful. Even though the systems are simple, it's definitely a trip hazard there. In terms of the treatment process, I think that's kind of developing knowledge at the moment. They have been used successfully. We used a particular design tool that we have access to, which is based on the theory and the growing kind of evidence of how real wetlands are actually performing. And so this tool has got the theoretical stuff, but it's also got the kind of the observations from treatment from wetlands as they're being installed. And what I'd say again about this is, you know, it's there's not a huge number of folk who know what they're doing in terms of designing these wetlands to do the right job. So we made sure that we're working with one of them, a chap called Rob McGuinness. And then finally, in terms of the biodiversity and the aesthetic and the cultural kind of parts of the design, I think this is easier for us than for the engineers. So I actually used to work in a couple of different engineering consultancies. So I think it is, you know, the catchment partnerships are particularly well placed to make sure that these solutions actually really provide the wider benefits that we're looking for. Recently, the Nature Recovery Network was launched, and it's, you know, the initiatives are there, the catchment-based approach, the Nature Recovery Network, and the partnerships are there to deliver these solutions. And I think, you know, inclusion within, you know, they find it easier to do this part of the design. So move on to the next one. Okay, so the optioneering process, you know, the first thing that I would say is that because we did our optioneering for the wetlands separate to Stantec and the team that was doing the conventional. So I think the first thing is very much that the two teams should have the same input data to base. So this came from the same starting point. And you know, I think that was largely true, but there's certainly some elements of data that would have been that we should have shared. And I think that would have really come out in the second point is probably my critical one. I think if we're going to get these blended solutions, then having that initial meeting between the teams who are doing the nature-based work and the more conventional design is a real opportunity, not just to you know, to transfer knowledge between the two sides, but it also is going to give us a much better chance of spotting the wider opportunities. For particularly in our case, it was for where we could site the wetlands. So I think that's for me, it's a key learning point, is that kind of meeting between the kind of framework contractor and the catchment partnership representatives. And then finally, including whole life costings. Again, Russell talked quite a bit about this in his, and I've got some kind of ideas or some examples from other work I'm doing, which I want to throw in there, because I think, you know, again, it is, if we're going to get those optimal solutions, we need to look wider than just the normal cost benefit analysis. So yeah, this is the cost benefit stuff. So I'll put in there the benefits wheel. Now this is a bit of this is something that the agency have adopted, Environment Agency, and I'm using this on a on a DEFRA evaluation for a program of nature-based solutions for natural flood management in that case. And so when we, you know, it's very simple. It's semi-quantitative, but it does give a good visual kind of feel for the differences between different different kind of approaches. So I think it's worth, it's a good thing to aim for initially if we're trying to take this much wider approach. And I think it's kind of particularly good because if you use the kind of the CABA evidence base with all the data on, you know, with the latest data I put in there is on health and well-being, but it's got data from flooding and from air quality and water quality, climate change. All that data's in there, so it does provide a much. Although the benefits wheels can look quite fluffy, they actually, if you tie them in with the evidence base that we've got and that we're improving, then I think, you know, they provide a, you know, real comparator between different solutions. Perhaps longer term, we should really, you know, a much more rigorous approach than this is to go for the 4 capitals: the social capital, knowledge, natural capital, and economic capital. And again, you know, I'm going to give it a go with this programme of £15 million worth of investment that DEFRA have put into natural flood management. And, you know, again, we know that assessing the benefits, particularly the social, knowledge and natural capital, is not easy, but it's then that we get a complete picture. And I was listening to Radio 4 this week, and you know, an economist came on and was saying exactly this in terms of getting those optimal solutions. We've just got to look much more widely than the normal cost benefit analysis. So some of the issues that I think we're coming up against is which affected our optioneering. So this is permitting and flood risk. So I think you know, we lost quite a number of sites because they were in the flood zone. But you know, and Rob had said that he's done the same in previous optioneering studies. Really, it's not that mad to build a wetland in a floodplain. It's just tricky to get it permitted, and I think so. You know, that's part of really one of my questions is whether we should start considering this, because of course, you know, sewage stream works tend to be in that kind of area, and the opportunities for wetlands tend to be in that area. So my kind of first feeling was that that the permitting a wetland treatment in a flood zone, if it's a polishing wetland, that's not that mad, but we need to take into account the impacts that it might have on maintenance longer term. But in terms of probably a direct treatment wetland, then that's much more of a consideration. In terms of permitting for groundwater, this is something that's quite sort of dear to my heart because I'm a hydrogeologist as well as an engineer, and I think, you know, we've got a lot of the tools we need for groundwater permitting, but you know, in terms of source protection zones, groundwater vulnerability, and so forth. But it's very easy to sort of just say that the wetland is going to be there's a risk that the wetland will contribute to particularly nitrate pollution into groundwater. But actually, if you think about the wetland, if you think about the wetland as part of the whole system, and whether the discharge into surface water was really just going into groundwater anyway, and whether any discharge into groundwater is then going to come back out into the surface water and through the hyporeic zone where it gets denitrified, there is there's a lot, that there is not many, that I don't think all the cases of wetlands, all the wetlands should be so restrictive. I mean, we ended up costing in impermeable membranes for all our wetlands, and again, I think if we're going to get to those optimum solutions, that probably isn't necessary in many cases, and so a bit more flexibility in the permitting approaches, I think, is going to be really helpful. And that kind of leads to my final slide, really, which is just I think it reiterates what Chris was saying at the start, and Russell, is that kind of flexibility, which we can see is coming, is really going to help with these kind of hybrid solutions. My kind of rule of thumb is that nature-based solutions probably do sort of 10%. Engineering is still going to do the heavy lifting. That's the way it's kind of working out in flood risk as well. So I think it is a small but very significant part of the picture, and that these areas where we need some flexibility, we just need to keep on having these discussions, and hopefully this workshop is a good place to join that conversation. All right, that's me done.
Okay, so over to me then, I guess. So hello everyone, my name's Alex Cook. I'm the Principal Catchment Scientist at Severn Trent Water, and I lead a small team of catchment scientists and catchment advisors. And I guess unsurprisingly, we're responsible for delivering our catchment management programs at Severn Trent. We've been doing this fairly successfully for the last, over 10 years now. But it's only the last year or so that we've been starting to look at how we can expand our catchment offering into the wastewater side of the business. It's only been on the clean water side up to now. So that's basically what I'm going to take you through with this presentation, with particular emphasis on what we've learned from our approach on the clean water side and how it differs to the approach being taken on the wastewater side of the business. Now, before I move on, I just want to quickly introduce my colleague, Matt Palmer. Well, I can talk about catchment stuff till the cows come home, but Matt's been the one that's really been driving the nature-based solutions work and embedding it into the wastewater side of the business. And he's going to take you through the optioneering approach later on in the presentation. So, Matt, I don't know if you want to just give an introduction to yourself. Drop you in it.
Yeah, no, it's a pretty good introduction. I'm a process engineer working in wastewater treatment capital projects is the way to think of me.
Cool. Okay, so Severn Trent's long-term vision is for nature-based solutions to become business as usual within everything that we do. So this is operating catchments which are carbon neutral, but they also require minimal operator intervention and ultimately deliver added value to all the communities that they serve. And as I've already said, they're already ingrained into the clean water side of our business, predominantly through the catchment management program. But we've also started working quite heavily in biodiversity, and we've got a number of schemes such as Boost for Biodiversity and Green Communities, which really do embed the nature-based solutions within the business going forward. The catchment team, so my team, have been leading on the work looking at catchment nutrient balancing, and so the feasibility of undertaking catchment interventions to offset some of the phosphorus around some of our work. And many of the sites that are already within existing clean water catchment schemes, and so we've already got high farmer engagement and really good levels of trust with the farming community there. So our catchment scheme on the catchment programme on the clean water side is known as Farming for Water, and we cover 44 catchments across our region, both surface water and groundwater, and it's essentially a large programme of farmer engagement. We offer advice and training to our farmers through agricultural advisors and specialist on-farm visits, or SOFA, we like our acronyms at Severn Trent, and a whole host of different schemes and initiatives where farmers can access pots of funding to implement infrastructure or land management changes which will benefit water quality. So the Severn Trent Environmental Protection Scheme, or STEPS, that's one of our flagship schemes. We've also got Farm to Tap, which is a payment for ecosystem services scheme that has been targeting metaldehyde up to now, but we're currently adapting it for other pesticides. We also offer things like annual pesticide amnesty, and then we've got a number of bespoke schemes for different catchments targeting specific pollutants as well. But we across these catchments, we look at pesticides. We also target nitrate, cryptosporidium, colour and phosphate in some of the catchments as well. And we deliver these through 7 internal agricultural advisors, but we've also got a number of partnership advisors through the trusts at the bottom of the screen there. And that has been touches on what Dave was saying with regards to the CABA group. It has been really, really effective delivering some of this work through our other stakeholders that work in these catchments. You get a lot more buy-in from the communities where we're running these schemes. So to date, what we've achieved is we've engaged with over 7,000 farms within our priority catchments. We've removed over 20 tonnes of unwanted pesticides through our pesticide amnesty. 46,000 hectares of high-risk crops signed up to our Farm to Tap scheme to target metaldehyde, and nearly 2,000 grants have been awarded through our STEPS programme. And the images on the screens here, just some of the things that we funded, so everything from pesticide sprayer washdown areas to low-input grasslands, lots of constructed wetlands, biofilters, and even signal crayfish trapping. And obviously all of these have a benefit to the water environment, in addition to reduced treatment costs for us at our assets. So over the 10 or so, 11, can't even remember now, years of running these schemes, we've obviously learned quite a lot, as you can probably imagine. And I'm just going to take you through 3 things which really stand out. The first one being how you manage uncertainty and risk through delivering catchment interventions. Obviously, they're not the levels of risk associated with their delivery are far higher than if you were to implement a traditional treatment solution. And how we've been managing these levels of uncertainty and risk has been just simply through increasing uptake of catchment interventions. So our Farm to Tap work is a good example of this. We did some modelling work which shows that we need a 75% uptake of metaldehyde reducing options in order to achieve our metaldehyde targets at our water treatment work, so the target being 0.1 micrograms per litre. However, catchment interventions are obviously highly dependent on the crops that you're inputting, the weather, the supply chain. There's so many things that influence catchment interventions. And so just to manage that uncertainty and risk around those interventions, we've actually been achieving 90% uptake of this. And so just to ensure that we can meet the target that we're trying to achieve. Another thing is utilising spot samples within the catchment. So we undertake a large programme of catchment sampling across all of our catchments, and not just for nutrients, but for all kinds of pesticides. But we've found that the monitoring, utilising that monitoring data isn't very efficient for phosphorus and nitrates in terms of monitoring compliance and progress of catchment schemes. And this is simply just because the signal of the different catchment interventions and the different work and the different sectors, it gets lost, and the signal gets lost within the catchment. And really, in order to monitor things like compliance and progress, you need to be taking spot samples at the field edge or the outfall itself. And this is consistent with what other catchment studies have seen as well, notably the demonstration test catchments. And then finally, building trust with the farming community. This can take anywhere from sort of 18 months up to 5 years. And so if we're going to be implementing catchment schemes on the wastewater side of the business, we might need a different approach where wastewater catchment schemes overlap with existing clean water catchment schemes. So on the wastewater side of the business, we're progressing a number of nature-based solutions. We've got 3 on the screen here, which are these are predominantly the ones that we're progressing. There are a few others in addition to this. So catchment nutrient balancing is the one that I'm going to be talking to you about today. So this is implementing catchment interventions which will allow us to relax. We're also looking at wetlands, which I've already talked about, and we're also progressing reactive media. And this is reactive media that can be implemented in addition to a wetland, or also within interventions within the catchment itself. And there's a number of benefits associated with these nature-based solutions. So not only are we as a business using less chemical, less carbon-heavy treatments, but the wider environmental benefits are so notable, particularly biodiversity, which you'd all expect, but climate resilience, water resilience, carbon storage, and crucially, the engagement with the communities that those catchment interventions fall within. So I'm going to just go through the catchment nutrient balancing work now. I feel like it's been a fairly long process to get to this point. We started over a year ago now, assessing, I think it was 33 different rural wastewater treatment works initially, and all very small works. They serve around 2,000 people or less. And we really did just a very high level analysis of how much phosphorus is within the catchment. Is there enough for us to go at, as well as for the farmers to to meet their fair share? And once we screened out a few, that left us with 17 different sites, and you can see these on the figure here. And a number of these, as you can see, fall within existing clean water catchment schemes. Now, of these 17 different sites, there are many of these are also being considered for the other nature-based solutions, so the wetlands work, the reactive media work as well. And so we've had to come together within the business to work collectively across the teams to establish the most suitable nature-based solution for each of those sites. So the process for catchment nutrient balancing is fairly similar to the process that we take on the clean water side with our investigations. We start by characterising the catchment itself, and this an awful lot of ground truthing feeds into this, so utilising our agricultural advisors, but speaking to the farmers as well, and utilising the other stakeholders within the catchment. Alongside this, we have been contextualizing the catchment in terms of phosphorus. So looking at the inputs, the outputs, the concentrations, how it links to the different land use types, different industries, different sectors. And then crucially, if a catchment scheme falls within an existing clean water catchment scheme, what have we achieved through that clean water catchment scheme already that benefits phosphorus? Once those two phases have been completed, we did actually drop a number of sites. I think we dropped 3 at that point, and only took 14 through to more detailed feasibility. So this is looking at the fair share principle, high-level sensitivity analysis, so looking at that uncertainty and the risk around delivery, and also a high-level cost-benefit analysis of the wider environmental benefits, predominantly biodiversity. And eventually we'll get through to a detailed catchment scheme design, which Russell mentioned in his presentation. But at the end of phase 3 there, the feasibility stage, we've dropped another 3 sites. So of the original 17, we're taking 11 through to a catchment nutrient balancing scheme. A number of hurdles. It's not been the smoothest of roads up to this point. There's been a number of hurdles along the way, and a number of discrepancies when you compare the wastewater approach to the clean water approach as well. So the first one we've already touched on already, baseline monitoring requirement of 12 months minimum and fortnightly catchment sampling within that. The graph on the right just shows how variable phosphorus can be. This is phosphorus on the River Severn across a 5-year period, month to month. And as you can see, the variability is so high. And so to get a statistically significant baseline, you'd require around 6 years worth of water quality monitoring to include not just different crops, but wet and dry years. And so the requirement for 12 months fortnightly sampling just isn't going to give you a good enough baseline in order to monitor this and evaluate how a catchment nutrient balancing scheme is progressing. And this kind of also links to uncertainty ratios. So a catchment nutrient balancing scheme is required to meet a 2-to-1 ratio to manage that risk around the catchment interventions themselves. So instead of delivering 1 milligrams of phosphorus reduction, you'd be having to go down to 0.5. And this is different to how we approach uncertainty and risk on the clean water side, which, as I've already said, we manage through increased uptake of catchment interventions. The elephant in the room is probably the fair share principle. As Russell's already said, this is, and Dave as well, this is the biggest headache, I think, at the moment. The fair share principle on the wastewater side is approached slightly differently on the clean water side. We're often encouraged on the clean water side to do catchment management schemes regardless of the source apportionment or the pollutant, whatever that may be, of the catchment. And this is obviously not the approach that's been taken on the wastewater side. But it's also what level of detail do you need to go down to with regards to fair share on the wastewater side? That's another question that I'd like to pose. And then the final one is these OTAs that Russell has mentioned. They're currently set up to run from a calendar year, which doesn't match the water company funding years. It also doesn't match the agricultural sector's funding years or the agricultural calendar. And so that to deliver a catchment intervention, catchment nutrient balancing scheme through catchment interventions with the farming community, the requirement for an OTA to run in that calendar year setup is causing us a bit of a headache at the moment. There are some things that we're progressing to mitigate some of these hurdles. They're mainly around the baseline monitoring, to be honest. we are progressing with alternatives in addition to that baseline, the standard baseline monitoring, water quality monitoring. The first one is looking at the biological sensitivity of different organisms. So these are organisms which are sensitive to phosphorus, and there's quite a lot of research out there on this total reactive phosphorus index. We're using this approach multiple times throughout the year in all of our catchments to not just capture the baseline elements, but we'll be doing the same sampling during and post catchment nutrient balancing scheme as well. Some of the other stuff we're looking at, things like soil monitoring on farms, farm gate nutrient budgets as well. So these are all obviously at the field and state level. And then at the catchment scale, utilising farm scoper again, just to monitor the broad changes of pre and post catchment nutrient balancing scheme. And that will bring it the wastewater catchments in line with our approach on the clean water side. And then finally, starting the implementation phase earlier in those catchments where we're already working on the clean water side. We've already got the trust and the relationships there with the farming community. So this is where I'm going to hand over to Matt.
Cool. This final slide is just to kind of reiterate points that Russell and Dave and Alex have made, which is how important it is for us to view nature-based solutions as options within a larger optioneering scheme. We will have quite sometimes conflicting nature-based solutions as a solution to our phosphorus drivers, and working out how to address those together and consistently is kind of an ongoing thing that we're working on at Severn Trent. So we do have a working group that looks at all of these solutions, but it's also about bringing in the expertise from teams like Alex's or from Stantec's or from the Rivers Trust. On top of this as well, we have an open challenge is that we do have to think, how do we appraise nature-based solutions? So, optioneering studies and conventional solutions have a set of criteria that are on the right that are quite important when picking the best solution. So we do need to be able to have systems where we pick the right option for each site. That may well be a combination of those nature-based solutions, or it might be the traditional treatment. So we're working quite hard to embed those working practices within the teams. And we found that it's best to have the traditional engineers embedded with those, because actually that's making the appraisal of those nature-based solutions better, even if we're not just relying wholly on the expertise of the individual experts in those fields. So it's kind of a call to arms really, to kind of how best as an industry do we sort of try to apply these solutions to their right application and give those opportunities to it. So thank you for listening. That's all I needed to say. I think they're handing back to Catherine.
That's great. Thank you to all of our presenters today. I have just made a little note that that we are running just a little bit over time. So if anyone does have 5-10 minutes for Chris just to lead us in a couple of questions, that'd be much appreciated. We are recording the session, so as I said, it will be shared afterwards if you can't just stay the extra 5-10 minutes. So Chris, do we have any questions to pose to the panel?
Hello all again. Yes, there's a few have come in, but by all means post your questions if you're just listening and haven't posted any questions yet. So first question that's come in regarding optioneering. In an ideal world, there would be an integrated team doing the optioneering for environmental delivery. So, for example, that would be made up of CABA partnerships and framework consultants, etc. However, there are some constraints around water industry frameworks. So is that sort of partnering and that sort of collaboration in terms of optioneering even possible within the water industry frameworks?
I can try and answer that. I think it's a fair question. I think it's a much bigger issue than we can potentially jump into here commercially. I think it's about working out what's the best for that optioneering study, especially upfront. So we kind of have to be able to assess what we need from say, an investigation into catchment nutrient balancing, who's the right people to do that. Whether our existing frameworks can provide that, then that's great. If they can't, then we do need to be prepared to venture outside of those frameworks or adapt them long term in the future. Absolutely, currently it is a bit of a constraint. I think it is something that we would have to look at going forward with our approaches to frameworks and embedding those nature-based solutions into them.
And do you think the sort of follow on from that, do you think we need some sort of cross-sector type of initiative? So what tends to happen is each sector is trying to deal with its contribution independently, but actually what you're trying to do is reduce phosphorus flows across the catchment as a team effort, but the regulatory frameworks are not joined up in that regard?
I think it's a good ambition. I'm not going to claim I'm necessarily an expert on regulatory frameworking. I think it's about finding where, that is ideally what we want to do, and how to achieve that in the fairest way possible. So possibly an ambition rather than a immediately available goal for me.
Indeed. We have another question. Oh, sorry.
I'm just going to add to that, Chris. I mean, I think the thing is, you talked about other sectors there, but the water industry is a regulated industry, but other buyers and people interested in catchment management, work in other non-regulated industries. So it's just finding that platform to bring these different sectors together. It is a great ambition. I mean, and there's lots of signatories of the Catchment Declaration, and that's kind of why catchment partnerships exist, and sort of the ideal vehicle to bring those different interested parties together. But it still feels like an ambition. But I'm hoping we're kind of already made a few steps down that road anyway. I don't know if Dave wants to take the opportunity to add anything from a CABA perspective there.
You may be on mute, Dave.
I'm on mute. Everyone has to do it once. I think definitely where we want to head, which is one of the reasons why you want to be involved in these kind of discussions, really. And I think it has so many benefits in terms of passing on skills to the catchment partnerships, so that they become a skilled part of the we build that technical capacity in that side of the thing. So I think what we've got to do is look for opportunities to do it and test it, because we're only going to find out how easy or difficult it is, or what the problems are, by when we actually start it. And one particular thing I'd say, we do have a memorandum of understanding with Stantec, which is we're trying to work in that way with one consultant. We've got another one who is also interested. So I think there's genuine interest. Everyone can see the benefits. We've just got to try and find a way of making it kind of practical and not expensive and time consuming and so forth. So that's the bit that will take a bit. The only way we'll find that out is by doing it and trying to work out the most efficient way.
Classic Environment Agency way of learning by doing.
And a follow on from that, really, I suppose, this is one from myself, really. I was reading an EA report recently. So currently phosphorus loads in the UK's rivers about 30%-ish from agriculture, rising to 50% in 2027. One of the reasons for that percentage increase is because of the impacts of water industry bringing their phosphorus loads down. But given that situation, where we're roughly sort of, if you like, 50-50 across those two sectors, obviously ignoring everyone else there in that analysis. If the agricultural sector is meeting all its statutory requirements, realistically, how much more can we expect them to do? How much more contribution can they make, which includes actually meeting their own fair share? What I mean by that is the water sector can always build another treatment process. The agricultural sector generally doesn't approach things like that. So realistically, how much contribution do we think we can get in the long term from the agricultural sector?
Well, for me, it's what is the mechanism to get the agriculture sector to move beyond compliance if meeting their own fair share is above and beyond compliance. So for me, there isn't regulation may not get us there. So it is payment for ecosystem services schemes, like bringing a water company in or a food producer that might that might help support and pull up the agriculture sector to do that extra little bit.
I mean, I would say that the regulatory approach is definitely not going to get us there. With the levels that we're after for nitrate and phosphorus, so that means we have to have some additional payment for ecosystem services type approach.
Okay, I'm just conscious of time. Another question that's come in regarding permitting. Will a more flexible approach to permitting benefit conventional treatment? For example, are there conventional solutions that are not being considered because of the permitting approach we currently have?
Feels like a question aimed at me.
Yeah.
I think the honest answer to that is it's quite difficult to give a good answer generally. I do think, not to get too into the detail, there are times where particularly tight permits in phosphorus or ammonia tend us towards a more single track way of dealing with that problem, whereas some flexibility might change the overall solution. But I think what we found, particularly when comparing with the Catchment nutrient balancing work, is that generally our approaches to phosphorus are fairly straightforward. It's 1 dose, 2 dose TSR. So the flexibility around there, there's quite a wide band as to where that would start to become useful. So it's a bit of a vague answer, I appreciate, but it's...
Okay, and I think we've got one more. I'm going to attempt this. I think there might be some sort of typos on the question, but I'll have a go, give it my best shot. Okay, so there's always a possibility that integrated catchment wetlands could get discarded at the optioneering stage, particularly if they're applied to small sites where there's relatively little chance to impact on the trade contributions to that. And you've got chemicals that are resilient to the treatment. So how is the industrial source considered for this aspect of the wetlands?
I think the best way to think about it is from a sewage treatment works process design point of view. We tend to treat everything coming in as one, and then if there's anything special about it, try and consider it that way. So integrated constructed wetland design tends to follow a what's coming in approach, i.e. in terms of phosphorus levels, and then work backwards from there if there's any particularly nasty stuff. There's quite a lot of evidence in the literature of specific industrial wastes being treated by constructed wetland type technology. So for me, it's not necessarily a defining factor. Whether you should treat that trade discharge with a wetland and then the sewage discharge with a separate wetland is an issue for debate. But yeah, I don't think it's ever particular, especially at small scale, I don't think it's ever particularly a go or no go reason. It's the overall proposal that kind of will push it in one direction or the other.
Okay, and Alex sort of mentioned baseline monitoring, and the I think you said you need 6 years of monitoring or something to get something meaningful. So you've got a whole farm cycle. So that where we are at the moment, there's a lot of uncertainty around the nature-based solutions and catchment contributions. Obviously, we need time to reduce that uncertainty, but where we are at the moment, what are the best mechanisms for reducing that uncertainty?
I think pulling together, so different, obviously there's multiple stakeholders in all of our catchments that are working, so being able to pull together the different data sets and not just putting them together, but actually being allowed to use them as evidence for a lot of this, particularly with the baseline stuff, to be honest. That's something that we've been trying to do ourselves. That would probably be the most immediate help to allowing these schemes to get off the ground, to be honest.
Okay.
I'd add to that. We could, you know, we're stuck with the evidence that we've got. We just have to make best use of that evidence, including local intelligence and knowledge. But we're not going to reduce all of the uncertainty. So I think, you know, we're going to get to a point where we can set out the evidence base and based on that make some, you know, what I'd call kind of no regrets decisions, but still with some uncertainty in those decisions. And, you know, we need flexibility really from the regulators to enable us to do this. And we kind of have got that in the guiding principles, and that these are trials, the catchment nutrient balancing trials.
Yeah. And I would have thought the level of if that's the right word, the intensity of ground truthing, for example. So on a traditional treatment works, you can put monitoring on the works. We understand that it's much more difficult to do from agricultural sources, but the level of ground truthing when we're designing the solutions, you know, that's as that covers a wide range, from just looking at a GIS plot and taking a view on that, to actually going out into the catchment and really getting into the details of what the farming practices are, etc. And obviously, as those details build up, the confidence in the work that's being done will build.
Exactly, and I think in Alex's slide, it's much easier to measure the performance of a particular mitigation, rather than try and capture the collective performance of multiple mitigations across the landscape downstream. And it might be that we're doing a sort of almost a nested based assessment where we're showing, we can model what mitigation measures we put in the landscape and say what reductions they're likely to achieve, and we can show that they're performing, you know, where they are in the landscape. But then we need to understand that it's going to take time. It might be, Alex, you said 6 years worth of data. I think it'll be at least that we're going to see that change in downstream water quality.
I mean, I think this is really important, because we can waste an awful lot of money on monitoring and it not tell us very much. And we've got exactly the same problem with natural flood management at the moment, and we're just really trying to navigate our way through so that we're just collecting data that moves us forward. So in my view, the methodology is to measure it intensively in sort of particular sites, and use the models then to scale up the prediction. And that is, that's really the only way that I can see that we can look at catchment scale impacts. The monitoring of them is going to be incredibly difficult and expensive. So I think what we're trying to do in natural flood management, and I think I hope it's a step forward, is we're basically creating an asset database of all the natural assets that we're creating in the landscape. And we're saying, have you actually put the asset in there? Have you put it in the right place? And then you've put the asset in there and it's in the right place. Are you looking after it? And that's what the asset database is there for. And that's that seems to me, all that data that we're collecting is all useful data that helps us increase the take-up of nature-based solutions and look after them and value them in the future. It also critically fits in beautifully into a natural capital approach. So you've got the asset database, you absolutely need that. So I think that's how I feel at the moment. But as I say, on my parallel project in flood management, we got challenged only last week by the insurance industry and actually a water company. They still want that monitoring. They want the monitoring to prove that what we're doing is effective, and it's a really difficult discussion to have. So I think we've got to keep on discussing this and gradually move to something that's pragmatic. And the key thing is just not to waste money collecting data just to tick a box.
Absolutely.
Yeah.
I'm conscious of. Sorry.
Yeah, I was going to say, Chris, I think we have to wrap up from our questions there, and I just want to say thank you to all of our attendees who've stayed with us to the end, and a huge thank you to all of our presenters today. Thank you for agreeing to take part, and we've had some good feedback already that people found the presentations very interesting. So I'll just say once more thank you to everyone, and do get in touch if you want to be kept informed with any more of Stantec's webinars in this Beyond the Asset series. Have a great day. Thanks.